Fraser plus guest. Speaker view. There we go. Why am I so low?
Tilt your camera?
Well, I think I just need to move my camera.
Okay.
Let me see. Move me over a little more. Give me a little more space on this side. Boop. There. Now we're a little more balanced. I had to make you smaller. Or bigger. No, wait, bigger. You need to be bigger. Hold on. No self-effacing jokes. Okay.
I'm just going to sit here and giggle.
Gonna cut that off. Cut that out. Okay. Now we're kind of the same size. Okay, so everyone, your job. Tell us what Musk is announcing. And thanks, Elon, for doing your announcement right in the middle of the show.
Yeah, we have no audience today. We know this.
Yeah. In fact, we won't even know what the announcement is. I'm not going to be watching Twitter.
And I had to shut Twitter because if I have Twitter on, it takes out my ability to stream to you guys. So, WSH crew, you're kind of like our only hope.
Yeah.
Please,
it's up to you.
Please type it into the comments.
You're our only hope. Yeah, exactly. You know what? I've turned off any way that I could possibly know what's actually going on. Okay. I mean, are some of you going to try and watch the Musk announcement and listen to us? That's going to be hilarious.
Oh, I've done stuff like that before. When I have to be in 2 mandatory telecons at once, it turns out if one's a guy talking and the other's a woman talking with different pitch voices, I can listen to a telecon in each ear and process it and hate myself completely. Don't try this at home, folks.
That's awesome. I want to show you something. Okay, here. Have you seen these yet? Someone's going to get a free advertisement. So this is a mini museum.
Oh, yeah.
Yeah. Have you seen these
They have
before?
those on Touch of Modern.
So this is Mini Museum 2, and the third one just came out. So I don't know if you can see what I've got. I've got a chunk of the asteroid belt. I've got Japanese star sand. I've got a chunk of medieval chainmail. Is this the small one? I think this is the small one. Yeah,
that's the small one.
Yeah, and then there's a bigger one too. So it's formal. SpaceX to send privately crewed Dragon spacecraft beyond the moon next year. You heard it. So let's just unpack that. They're gonna send, I guess, a Dragon capsule beyond the moon, kind of like what the SLS did, or when they put that Orion capsule out onto that sort of that orbit out beyond the moon. There's like a translunar orbit that you can do with a free return. Next year. And of course, whenever Elon Musk says something's going to happen on a certain date, we know what that means. It's gonna take a little longer. Oh, and the point of the mini museum, I know I'm in attention deficit disorder right now, is they've got the version 3 has just come out. So this number 2 was purchased by my lovely wife. Once they're gone, right? Like, yeah. So that you can't get the 1 and the 2, but the 3 is in Kickstarter right now. I think it's like $199 for the small one, the one that I've got.
You can occasionally find the 2s on retail sites. I've seen them on Touch of Modern. Yeah.
Okay. And the first one I think is gone. So yeah, first there's a Cray supercomputer, petrified lightning, tree that flew to the moon, or a seed that flew to the moon, mammoth meat, which is cool. Anyway, free advertisement. There you go. Okay, let's. I'm gonna say hi to some people.
I have Twitter on my phone.
Oh, don't do it! Don't do it. Adam Synergy, Bert Clankar, Gouts4, Giselle Sabarin, Glenn Heck, H Roll, L Torture, James Haney, John Suffield, Larry Beckham, Michael Meyer, Nancy Graziano, Ross Betts, Sergio Botero, Tech Tang, Tony Raggett, Yov Landsman, and Zach Cody. Hey, everybody. Welcome to Astronomy Cast. Okay, cool. So if you have no idea what it is that you've stumbled into, we are going to be recording a live episode of Astronomy Cast, our long-running show all about space and astronomy, listened to by 60,000 people every week. That's Dr. Pamela Gay. I'm Fraser Cain. We'll take, I don't know, whatever my whim decides in order to record this show, and then when we're finished, we'll stick around and we'll answer your questions about space and astronomy. And specifically, what I suspect what we're going to do is just talk about Elon Musk for half an hour. So, you know, that's what's going to happen. And today we're going to talk about continental drift.
It's a thing.
It's a thing. Okay, great. Do you have anyone have any questions? Anyone unclear on what's about to happen here?
Hey, go sign up for Cosmo Academy classes if you're interested in taking classes that start, I think, later this week. So go sign up. They may start next week. I should know these things. I don't, but cosmoacademy.org.
Okay. Done. Let it begin.
Okay, I'm pressing record.
Let's do what must be done. Let
It's
what must
recording.
be done.
It's not using the right mic.
Oh, sadness.
Fail.
Wah, 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 fail. Okay, say when.
Hold on. Blue icicle. There we go. Pressing record. It's recording. Hi, Chad.
I am also recording. Hello, Chad. He's actually in the town right now. So we're going to hang out probably today.
Cool.
Okay. Here we go. Astronomy Cast, episode 441, Continental Drift. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific, and the Director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good. I want to remind everybody, I put in a little ad into Astronomy Cast, but for those who are listening, Dr. Paul Sutter and I are going to Iceland in February 2018 to take pictures of auroras for a week, and you should join us. So if you have ever wanted to put that on your bucket list and take pictures, or hang out with me and Dr. Paul Sutter, begin. This is what you want to do. You want to go to astrotouring.com and sign up. You can register until August. You can even cancel if plans change and you decide that Iceland is very cold and you don't want to be there in February. I understand. But anyway, that's just a thing that's happening, and you should totally join us. And if you can't join us for the eclipse trip. So that's another thing.
Because Iceland's easier than St. Louis.
Exactly. Yeah. We want to do a couple of these kinds of things every year, I think. They're so much fun. Have you got anything in the shameless self-promotion department this week?
Not this week. Nope.
Okay. CosmoQuest is awesome.
Go do science.
Go do science. Here we go. So you want to travel the world, but you don't have a lot of money? No problem. Your continent is drifting across the surface of the Earth right now. In a few million years, you'll reach a destination. So today we're going to talk about continental drift. Well, actually, this is part 5 of our Destroy and Rebuild series. So now we're going to talk about how the Earth rebuilds and destroys at the same time.
It's kind of doing all the things. It's one of these things that it always mystified me growing up, that we don't have like a rock we can pick up and say this rock is 4 billion years old. There's some pretty old rock on Earth, but for the most part, any given chunk of planet is probably only a few 100 million years old. And that's weird for an object that's 5 billion years old.
And you would expect the world to be to be able to have rocks from the world. So this is obviously a mystery that has, puzzled geologists for a long time. How did they start to figure out what was going on?
Well, the way they figured it out was actually a weatherman looking at the map and going, s- my audio stopped. There it
Uh-oh.
goes. Sorry, Chad. Sorry, there's an edit in there.
Okay.
Um, so it all started with a weatherman pretty much looking at the map and going, South America and Africa look like they should fit together. And
Like
he
nobody
started
noticed
looking.
that?
Well, I don't know.
Yeah.
I
This
don't know.
this is the story anyway. Yeah.
This is the story. But he was the first one that I've found documented that went beyond going, those two things can fit together, and going, there's these weird fossils on both
Right.
sides of where they match. There's these rock formations on both sides of where they match. And in fact, there's certain critters like remains of a freshwater Mesosaurus, which is a kind of reptile that looks to me like a crocodile.
We have them
That
here. Well, we had
yeah,
we had them here. So we actually have mesosaur fossils that are found in the local river here.
and there's a band of them that goes from this what is now the southern tip of South America to essentially Cape Town, South Africa. And then there is a kind of fern that basically snakes its way from South America through Africa, up through India, across Antarctica. We find plant fossils in Antarctica, and
Of
then
course we do.
all the way over to Australia. And if you trace out the fossils and where they match, and you trace out the mineralogy and where it matches, it's like the puzzle pieces fit together. And there's an even cooler underlying picture with the fossils and everything else.
So we've got the situation where the puzzle pieces of planet Earth fit together, and you've got items on one side of the puzzle on the east coast of South America that match up with the items on the west coast of Africa, just hammering home the evidence. But this is a fairly new theory, right? I mean,
Yes, so
when was
this
this
was
developed?
this came out in 1912. It was Alfred Wegener who figured it out. And the thing was, this was that point in time where we were still figuring out, like, how does the sun work? We were still
Yeah.
figuring out
What's a galaxy?
exactly. There were a lot of these now fundamental questions that we just couldn't make sense of yet. And looking at this, what I find absolutely amazing in retrospect is people grabbed onto the idea that continental drift makes sense before we even knew what drove continental drift, because the puzzle pieces fit together so well and it just seemed to make sense.
That's really cool. And now sort of the more modern thinking, the more modern understanding, what is going on? How is this continental? What is the mechanism for this continental drift?
So the mechanism we only sort of kind of understand, and that's the cool part, is this is one of those theories that we're like, okay, this clearly is what's going on. We now have well mapped earthquakes. We know this is a thing, but we're still figuring it out. We know the energy that drives the continents moving is the energy of the earth cooling off. So it's driven by heat energy. It's motivated in part by the convection of basically molten earth inside of our planet, and this convective slow boil causes the floating continents to slowly bump and grind and duck under one
I love
another.
I love that idea, right? That you've got this sort of lava lamp with like a waxy crust on top of it, and the bubbles of convective cells of in the lava lamp's case of it's whatever is the stuff, the oil and the wax and stuff that's inside of it are sort of causing the crust to float around, the continents to float about back and forth as the forces churn underneath on the Earth. It's a really cool idea.
It's a super cool idea. And what's really neat about the way it works is we have new crust getting formed. And it turns out that it's just a little bit less dense than the older stuff that's been around and gotten squished and has increased in density over time. And so we find that also gravity helps drive continental drift, where you have places where the much older continents are starting to subduct underneath younger bits of land. And so you have essentially three different processes going on. You have areas with subduction, which is, again, the one piece going under another. You have areas where the plates are diverging apart from one another. We have this in the middle of the Atlantic Ocean. And then you have what are called transform boundaries. These are the boundaries where continents are essentially rubbing up against each other as they pass not so gracefully past one another.
And so where are things going? Like here in North America, on the west coast of North America, I'm actually on Vancouver Island. I believe I've got my own separate plate. I'm on a different plate from what's going on over on the mainland. But where is everybody going?
So different. There's the main plates, and then there's crackty bits of the
Correct.
different things that are doing different things. So your area of the continent is trying really hard to head towards Japan. You're making a break straight west, whether you should or not. That's what you're doing.
I've always wanted to go to Japan.
Yeah, it's a beautiful country. I highly recommend it. You're doing it the slow way.
That's fine.
And then you have California, which is doing its best to head straight north. And you have different bits moving in different directions. The African continent is gradually moving north and east as it's essentially crushing into the Arabian Peninsula. You have Europe moving north and east as well. You have all sorts of different movements, which are essentially leading to the Pacific Ocean area, the plate underneath the Pacific Ocean, crashing into Japan and Australian areas.
I think we've got some other dramatic examples, right? We've got things like India, which is smashing into Asia so hard that it's causing all of the mountain ranges there. You've got the Great Rift Valley in Africa, which is like cracking open. You can see where the Earth is tearing itself apart, and one part of the continent's going one way, and the other part of the continent's going another way. Like, once this discovery was made, I wonder how hard they fought it, right? Or did the geologists go, okay, yes, this is it, this explains it?
It wasn't instantaneous. Nothing in science is, except for maybe the discovery of dark energy. There was tens of years lag between Wegener coming forward and saying, and have you guys noticed? And people going, yeah, that is indeed what we're seeing. And what it took to make the change was plotting out the earthquakes, realizing earthquakes tend to follow these boundaries, and tracing out all the boundaries and how Wegener had worked to put things together, and realizing, yeah, it's the fossils, it's the minerals, it's the earthquakes, all of this painting a single picture.
Well, so let's run the clock in two directions here. We can run the clock forward, of course, and we can run the clock backward. Let's start with backward, because I think this is one that people are most familiar with. What did the continents look like in the past? Because we are the result after millions, even billions of years of continental drift. So what did it look like in the past?
Well, I think the thing that people are most familiar with is about 300 million years ago, many, but not all of the land masses were unified into this Pangea landmass, this landmass where we saw North America, South America, Asia, Africa, all fitting together along with Antarctica into one giant piece. And this is where that fossil and mineral record that we were just talking about comes from. But there were still a few pieces that were off doing their own thing. Siberia and what became the Baltic nations were hanging out on another part of the planet. So we had the bulk of the landmass going down towards the South Pole, but there are a few other pieces. And what always has amazed me is we stop at Pangea in when we talk about the plates. History doesn't stop there. That was just a moment in time when all of what are today's continents were combined into one landmass. Earlier in history, there had been different land masses. There had been different points of everything merging together. And as we keep winding back the clock, we find different points with different sets of continents. So 490 million years ago, there was the single continent of Gondwana. That was one of the things that some things go back to.
Right.
But it was built out of even earlier stages that broke apart. And in the future, we could end up with great supercontinents yet again.
I kind of imagine, right, like all of these continents floating around, and they sort of smash up in one area, and then they go the other way around and then smash up in another part. You would sort of imagine that, right? If you could imagine sort of this floating chunks of wax on the surface of that. Once they'd piled up to a certain point, they would then flow back. But there are parts, I mean, are there any parts of the Earth that are left over from the initial formation, or has everything been recycled at this point?
We keep finding new oldest rocks. There's been a few found in Canada. There's been a few found in Africa. But there's no one part of the planet that you can point at and say, and this section of the planet is extraordinarily old. There are just small sections that have rogue rocks, essentially.
Right. But still, like we can't, like if we didn't have an independent way of knowing the age of the Earth, thanks to the meteorites, we would really have no way to know how old the Earth truly is, because there is no rock that is older than some of the stuff that's formed just within a billion years after the formation of the Earth. We just don't know.
And well, we keep coming across things that help us get there. So we will find fossils from different periods. And it was, in fact, yesterday was the anniversary of the discovery of carbon-14, which gets used to do a lot of radioisotope dating. And we can go back more than 300 million years with the fossil record. It's just, how do you date a rock that isn't embedded in fossils? This is where it gets messy. And so trying to figure out, well, okay, so maybe you have this rock over here that has this set of isotopes that it can get used for aging. This is where it gets hard unless you're relying on the radioisotopes within fossils.
Right. I mean, they have like uranium, and they have other elements that can be used to look for, that have longer half-lives, that can be used to look further back. So this is, of course, Astronomy Cast, and so let's take this concept of continental drift and look elsewhere, both in our solar system and really in the universe. Is there any other place in the solar system that has continental drift?
Not like we're used to here on Earth, where we have our set of fairly well-defined continental plates and smaller plate tectonic events, like your part of Canada trying to head towards Japan.
Yeah. See you later.
We'd thought for a long time that Mars didn't have any plates, but some new papers are starting to hint that maybe it has two plates that are just sort of going back and forth like two things floating on top of a boiling or a boiling kettle. What's cool, though, is Venus seems to have avoided the whole plate tectonics thing altogether. And instead of having these plates like wax moving back and forth and back diverging and
Mm-hmm,
going
mm-hmm.
under one another, it seems to simply have flipped its whole surface now and then. There are hints that instead,
Like it just like turned itself inside out.
yeah, I'm done. I'm just gonna
Yeah.
give off a whole bunch of heat right now, have massive volcanic eruptions, and resurface my entire world all at once. Um,
Wow.
yeah, so there's different models. And one of the things that I'm really hoping to get to see over time is, for instance, how do you handle something like Io that's constantly resurfacing itself? Can we, if we watch it long enough, start to see some of these longer lasting volcanoes moving
Right.
relative
Right.
to one
I
another?
mean, you
So,
would
will
think
we
that
find plates there?
you would think that Io would be a classic candidate for this kind of a thing, that it's clearly got so much volcanic activity and it's got these active volcanoes. How long have these things been running? What is going on there? But here on Earth, I mean, we have really sensitive laser rangefinders that are used to measure distances. We don't have such a thing on Io. NASA, take a note. We need some kind of plate tectonic, instrument package to be landed on the surface of Io.
And then looking at worlds like Europa with its ice that is constantly moving, we see the cracks, we see the tears, and do you have masses that in some ways act like plates over the ocean waters? Uh, Here you have a different gravity, you have a different way of thinking about it, but we're still working to understand the underlying physics in plate tectonics and continental drift. So, can we someday treat some of the ice masses the way we treat land masses here on Earth?
Yeah, I mean, the surface of Europa clearly looks like there's some kind of process that's going on. You got these amazing cracks and like scars and scrapes, but also regions that are very smooth. Like you don't see a lot of craters on the surface of Europa, so you know that it's being resurfaced somehow. And so just imagine, this is even a much better analogy, right? Because you got boiling water, you got frothing boiling water in Europa because of the tidal forces, and then you've got this ice on the surface, the shell that is in contact with space, and so it's cold and constantly refreezing, and then this cracks opening up and water welling up, and then other areas subducting underneath, things like that. But even this idea of cryotectonicism is kind of, it's thought that this is everywhere, right? But it's not just Europa, but maybe we're seeing this on Enceladus, we're seeing this on Ganymede, we might be seeing this on Pluto. It could be possible on, right? Like this is perhaps one of the dominant factors that's going on with these worlds.
And it all comes down to, is the surface being remodeled through a process driven by the energy of heat trapped in the world from its formation and from its tidal events? And is it convective processes and gravitational driving forces that are causing this motion that we're seeing?
Yeah. I mean, just to look at Pluto, for example, I mean, there's these amazing plains of just very smooth ammonias and ices and methane and things like that. And then you've got these mountains of like water ice. And so you can just kind of imagine the same processes that are happening here on Earth, but where it's rock, are there happening and it's water, which is, it blows your mind. So let's talk about, like, let's go further then. So imagine crazy alien versions of this, places that are tidally locked. Like we discovered this new announcement of the TRAPPIST-1 planets. They're tidally locked. They orbit their planet within a day, 1.4 days is the closest one out to 20 days at the furthest one. Could we be seeing some kind of continental drift, tidal forces on those sorts of planets?
It's there's so many different scenarios that you have to worry about. What's tidal lock to what sorts of synchronicities are there? To go to a much simpler case where we're only looking at two bodies rather than eight with a star and seven worlds. If you have two fairly similar sized planets that are tidally locked to one another, you can imagine that over time the continents will all slowly drift so that one set of land masses is constantly facing the other set of land masses. And that would be disconcerting. Because, I mean, think about it. The one world has the potential to constantly eclipse the other and vice versa, depending on their size and distance ratio and their sun size and distance ratio. Imagine if you were cursed to basically always be eclipsing your star with your other planet's cities straight overhead.
Yeah.
So the tidal locking could influence how the continents drift and then lock them into a place where they're just locked facing the other world.
What does the future hold for the Earth? Are we going to go on continental drifting forever? What would stop it? Are we going to become like Mars? What does the future hold?
We will eventually cool off. It's one of those in the fullness of time things where people, it's a every few years you see a new calculation for will the sun consume the earth or not, and you see a new calculation for how long is it going to take for the earth to completely cool off and lose its magnetic field. In the fullness of time, given we're not eaten by the sun, the earth will cool off and the continents will stop drifting. But until then, our world is constantly building new oceans. It's building new land masses. What drove me to suggest this show was the realization that New Zealand, which is one of the youngest bodies of land on our world, it doesn't even have like indigenous mammals really, because birds could fly there and, well, not so much for things that weren't birds.
Right.
And it's so young that it hasn't had big animals get there through other means. There was no bridge like we had from Asia to the Americas. So this young piece of land rising up out of the ocean, it's being realized it's a new continent and will grow and expand over time and over earthquakes and build safely down there, folks.
Yeah, that announcement was made just in the last couple of weeks, right? That New Zealand is now brand new baby actual continent, Zealandia.
Yeah, and, Zealandia.
Yeah, congrats, everyone in New Zealand. You're members of the Continent Club. Very auspicious. Well, thanks, Pamela. We'll talk to you next week.
My pleasure. And now we save our recordings.
$4.41. Did you see that Geo did a big live
500th
stream?
episode? Yeah.
For his 500th.
Things that we should consider. We still have like a year or so to go, though, before we get there.
Well, we've done 24-hour-long, day-long events. You know, just get a stream of astronomers in to talk about different research.
Oh, yeah.
That'd be fun. Okay. I saved. I'm going to upload, and then we'll talk. So, did anyone know what's the announcement?
The announcement appears to be that in Q4 2018, humans to space, Dragon 2.
Shouldn't they take the Dragon to the International Space Station first?
I don't know if well, first of all, going to the International Space Station is one of those you have to like hit all the NASA check boxes. So the certification process.
So you don't need any certification at all. You just need volunteers, really.
Well,
Yeah.
I'm sure there's
Okay.
FAA regulations involved
Right, but
with,
you don't need to jump through NASA's hoops.
right. It's a
Okay.
different set of
Yeah,
hoops.
yeah, yeah. No, I think that's a really good point. Is like sick and tired of waiting for NASA regulations, just do it on your own. Huh. That's interesting. Um,
It's a thing.
um, Adam Synergy asks, where is SpaceX going to get astronauts from? There's going to be a list of volunteers out the
Yeah.
door.
Yeah, they're going to be able to get high quality candidates. It's,
Yeah.
yeah,
Yeah, no problem
not a
there.
problem.
Yeah, and they will get no shortage of people wanting to participate in that. Well, hey people, do you think I should do an episode of the Guide to Space on this?
Yes.
Well, I don't know. We just did one on the TRAPPIST-1, but should I just drop everything and do an episode on that? You tell me. I'll look at your votes in the chat. I don't know if it's big enough news. It's an announcement, not an actual launch. I need to think about it. Anyway, so Richard Strausel, would there be any way to detect tectonic activity on exoplanets?
No.
No, that'd be tough. Because, like, the way you would... I've read research reports that it would be possible to detect continents and oceans on other worlds. That you would, once the technology gets good enough, you would be able to see the
Differences
changes
in
in
albedo.
albedo, yeah, and that would tell you how much of it is continent, how much of it is ocean. But it's like literally, it's going to be 2-bit graphics, right? It's going to be this side is more continenty than that side, and that's sort of like the best you're going to be able to do for a long time. But when you think about how continental drift happens here, I mean, we need GPS and laser rangefinders that are set up with incredible care to actually track that. So, Rebecca wants to know how much a ticket is.
How much? What?
How much is a ticket to fly with SpaceX to be one of the astronauts to
I
go
think
beyond the
that's a
moon?
matter of getting hired, and that's
Maybe.
harder
No
than
way.
paying.
No way. They take
For
money.
that first flight?
Yeah.
That first
Yeah,
flight is
Richard
going to be an
Garriott, I'm sure,
employee.
is lined up right now, waiting, ready to go, ready to plunk down his $20 million to go beyond the moon. He'd do it. He'd do it. Okay, so from Richard Strausel, from Arjun, spinning planets seem to have bands of weather. What kinds of weather patterns would occur on tidally locked planets? Here's the question there.
So they're still spinning. They're just
No, they're
spinning.
not. Well, they're not spinning compared to their star.
Right. No, they're so you have two tidally locked you have planets that are tidally locked to each other.
No, to the star.
Oh, a planet that's tidally locked to a star. Yeah, it rotates once for every one time it goes around. There it would probably be thermally driven weather patterns where you have the superheated air on the side facing the star and the non-heated air on the side away from the star, and you end up with like two convective cells in some of the models I've looked at that are just whipping the air around.
I mean, it sort of depends on the world and the thickness of the atmosphere. Like Venus rotates so slowly that it might as well be tidally locked to the sun. It takes 100 days to rotate. I forget the number. In fact, it goes so slowly that the sun moves in the wrong direction. Oh, actually, it orbits backwards. Anyway, you could walk faster than the sun moves through the sky, right? And yet Venus is exactly the same temperature everywhere on the whole planet, no matter where you are, day side, night side. It's all the same.
And it has massive winds.
Venus has massive winds high up, but not once you get down. Once you get down to into the 90 atmospheres level, it's like seawater, right? So so we don't really know. Now we've seen worlds, exoplanet worlds that are like hot Jupiters that are tightly locked to their star, and they've got enormous winds, ferocious wind speeds, and doing that exact thing where the wind is being heated up on the one side of the planet and pushing off to the other side. But there's kind of no rhyme or reason to it. So, man, everyone's talking all about the Dragon capsule in the chat, which is interesting. So,
Well, do you want to end early so that you can go read about the Dragon capsule?
no way.
Okay.
No way. These people here in Astronomy Cast, they're way more important.
Okay.
Someone's about to get banned. Let's see. What else? We've got some questions. Okay, so Sergio Botero, you mentioned the once upon a time there was Pangea, and then the continents broke apart, and then we'll have another Pangea in the future. Does this mean that the breaking and gathering is a cyclical process?
Yeah, it actually is. Prior to Pangea, there was actually the Rodinia supercontinent about 1 million years ago. So it seems like, yeah, every 500 million year or so, you have a new supercontinent, because that's how long it takes for things to
Right.
bump into one another. And like a bad day playing bumper cars, everyone gets tangled together.
Right. Bumper cars is a great example, right? Where you've just got to get this collision together, and then everything kind of collides on the other side, and then it comes back together and just sort of bounces back and forth. And I really feel like that analogy where you've got this sort of water bubbling and the plates are merging together.
Yeah,
is sort of the process that's going on there. Super fascinating. So from El Torture, what about the tectonic movements on the moon? Could we detect those, or is it already equalized to zero movement?
it's equalized to zero movement. We do
Right.
see that there is seismic activity in the moon, but that is collisionally driven as far as we can tell.
Right. So we don't see any new processes resurfacing the moon, so there is no tectonics or
Right.
continental drift on the moon.
Yeah. I
Let's see.
accidentally made caffeine-free tea.
I've had like 4 cups of coffee. I'm ready to go.
Oh man.
Hot House. John Suffield. Hot House by Brian Aldiss. A good sci-fi book about living on Earth in the distant future when it's tidally locked to the sun. That's a long time, and you like beyond the age of the sun for the Earth to be tidally locked to the sun.
Dang.
Yeah. Michael Harmer, could anything disrupt the direction of the continental drifts?
That's part of the we don't fully understand how continental drift works part. We don't know why things are going in the direction they're going.
Yeah. Explode a bunch of nuclear bombs. Well, because back in the atomic age, they were using that as an idea for literally everything, right? Want to create the Panama Canal? Use nukes.
Not every idea is a good idea.
No.
And I just realized the tea I'm drinking while uncaffeinated is totally relevant for today.
Keep going back. No, you're too close. Like right by your face, maybe. There it is.
Right there.
Spice, dragon, red, dragon, spice. Whoever controls the spice controls the universe.
And the dragons will get us beyond the moon.
And the dragons are going to get us. And the red dragon is going to get us beyond the moon. So you really did choose a good tea for today. But in the future, I would recommend more caffeine because you look a little sleepy.
Yeah, I was.
Oh, there it is. How long, James Haney wants to know how long it will take for the Great Rift in Africa to split that region of the world.
This is one of those things where we don't understand the process well enough to know how long it will take. There was like a moment when the rift opened up that was captured by scientists who were there. It's happening in these stochastic bursts of, and now we're going to rip open a whole lot more, and now we're going to rip up a whole lot more. but we can't predict the frequency at which these rips are going to happen.
Yeah. Larry Beckham wants to know, will life on Earth end with the magnetic field? Is there time to adapt? So I guess what Larry Beckham is talking about is this idea that the magnetic, right now the North Pole is one pole of the Earth, the South Pole is the other pole, and every now and then, every few 100,000 years, which pole is which flips. And the part that's just amazing, right, is you can see like lava flows. Have we done the magnetic pole flip? We should, if we haven't, we should do an episode on that.
Okay.
So you've got this volcanic eruption. You've got this lava that's pouring out of a volcano, and for one part of it, the crystals are aligned with one direction of magnetic flow, and then just a very short period of time, the magnetic field lines are realigned in the new direction, and it is almost instantaneous, which is
well. And what's cool is, and I should have brought this up in the show, with continental drift, they can see the rotation of the continents in how the essentially fossilized magnetic fields change their alignment as the continents move.
So we are due, just, we've had this conversation about things that you think you're due for and things that you're actually due for. We are due for a continental. Oh, I see. Okay. All right. So I guess so let's finish up this idea, right? So we're essentially due for a magnetic pole flip. Will that, would there be time to adapt? Life has been here for billions of years. It's gone through many of these reversals. So in theory, yes, we don't know. We don't see necessarily worldwide, disasters and die-offs when these pole flips have happened. So in theory, it can happen. But actually, what Larry is talking about is will we lose the field? So if right, and then what impact would that have on life?
So life underwater and life under dirt, for lack of a better phrase, earthworms.
Mole rats?
Yeah, will be fine as long as they stay there and as long as the planet stays warm enough to take care of them.
Yeah.
With the loss of our magnetic field, we'll have accelerated loss of our atmosphere because the solar winds will be able to more readily strip it off. With less atmosphere, that's less insulation. Bad things occur. They occur slowly. So there's the potential that some life forms will be able to adapt, but not us in our current format.
Without the protective magnetic field, we are doomed to mountains of radiation. And so you're saying like maybe there's bacterial forms that could withstand that kind of radiation from the sun and from space, but not larger life forms with all of our fragile cells.
So whale sharks will be fine
because they'll be in the water.
Yeah.
Once you're underwater, you're fine.
Right. So it's us land dwellers that are slightly doomed unless we do things to protect ourselves artificially. Yeah. But even then, over time, the planet will cool beyond just the thermodynamic cooling, but it will cool because the atmosphere is getting stripped off.
And this is one of the concerns with the potential planets on TRAPPIST-1. They're orbiting around a red dwarf star, and a red dwarf star they're renowned for having killer flares that are hundreds of thousands of times more powerful than the kinds of flares that the sun does. You think about the Carrington event, that would look like a picnic compared to an actual mega flare on a flare star. Now, TRAPPIST-1 doesn't look like it's a flare star, but any life on there would just, even if it had medium-sized flares from a red dwarf star, and they're that close, right? Like, think about how far away the Earth is. These things are, the closest ones are the closest sum of Jupiter's moons to Jupiter. I mean, this is, you are right in the shotgun blast of a deadly flare. So this is the big challenge. This has always been the big challenge with these flare stars. It's just with red dwarf stars. I mean, the vast majority of stars in the Milky Way are these red dwarf stars. They're the places that we can be finding Earth-sized worlds orbiting very easily. Problem is, they suck.
They get a good thorough billion years of sterilization.
Yeah. So let's hope life can get cracking after that. But based on what we know here, there are, oceans, deep vent methods, things like that.
Yeah.
Does Venus, Arjun asks, does Venus have a magnetic field?
I don't know. I simply don't know.
Yeah, we know Mars doesn't. Let me see.
And this is where we Google for you.
Let me Google that for you. No.
It has a weak one.
It has an induced magnetosphere.
Which means it used to have a magnetic field and it got locked into the rock.
Right. So it has no intrinsic magnetic field the way the Earth does, but it has an induced magnetosphere. So you're saying like it's baked into the rocks.
I believe so.
Yeah. Interesting. So in general, no, which is of course one of the great challenges, right? Which is that if we were actually able to terraform Venus, then don't laugh. We terraform Venus, make it habitable again, live there. Then you'd have a radiation risk. You'd get sunburns, and that would be bad.
Not like the hydrofluoric acid.
No, you've
atmosphere is bad.
You've cleaned up the sulfuric acid rain. You've locked up all that carbon dioxide with mountains of limestone that you've dumped into it and magnesium rocks, and now you've scooped up all the rest and you've taken over to Mars that really could use all that carbon dioxide. You've made buildings out of it, and now you've got a great big sunshade over the Venus that's cooling it down, and now it's a lovely place to live.
You've been reading Kim Stanley Robinson as well, haven't you?
I don't think has he done a Green Venus series yet?
No, but in one of his books, I think it wasn't like a Red Mars series, but I'm pretty sure he talked about it in 2341.
Richard Strozel says, until the surface turns inside out.
Yes,
so that's
true.
That's a very bad day when your entire surface just
it's a
over.
Superman kind of day.
Yeah. Gordon Dewey says, what would you do with the horrible pressure? You would lock it all up, of course. Easy peasy. We've done a bunch of articles about terraforming things. It's all crazy, right? And of course, this is the irony that just kills me, and we talked about it in a previous episode, which is like, as soon as you hear that Venus sucks, your first thought is, how can we fix it? You hear that Mars sucks, and we're like, how can we fix it? Hey, what's a place that doesn't suck? Earth. It's great, and we should really stop messing it up. That's all. That's all we got to do. Drive a little less, and then maybe we don't have to
order fewer things overnight delivery.
And then we won't have to think about ways that we're going to have to fix Earth. So, yeah, I find that so. I'm going to go down a rabbit hole here for a second, which is like just this idea, like you tell people that the Milky Way is going to crash into Andromeda, right? And then people are terrified. They're like, what can we do to prevent this, right? Or the fact that the sun is going to die in 4.5 billion years or 5 billion years from now, and people have this existential crisis
that they don't have over climate change.
Belt, right? Like, wear a seatbelt. Think about, decrease your simple carbohydrates. There's a lot of things that we should do that we should be more concerned about than the
Right.
heat death of the universe that's going to happen in a Google years,
That's
right?
my favorite. I have to write that down.
Did I just make another quotable?
Yes.
What was my quotable? Should be more concerned about
There are so many things we need
to
to
worry
worry
about
about more than the heat death
of the
of the
universe
universe.
in a Google years.
Name Google
Yeah, there you go.
years.
Are you tweeting that?
I will.
All right.
I haven't yet, but I will.
Noel Ruppenthal says, I'd rather build 1,000 O'Neill cylinders than terraform another planet. Boom. That's it right there. If I was in charge, we wouldn't be going to Mars. We wouldn't be going to the moon. We would be living in rotating O'Neill cylinders. But I'm not in charge. I'm just a Canadian.
Okay, if you like the idea of like O'Neill cylinders and self-replicating robots and all that sort of stuff, random product plug, because this is apparently what we're going to do today. I Am Legion, I Am Bob is a fabulous book worth reading.
Okay. I Am Legion, I Am Bob. Noel Ruppenthal would happily go to the moon with Musk. Oh, I see. Elot Averon says, who wants to go to the moon with Musk? Yeah, put your names in. We'll pass them along. So you just go ahead, just put, no, I don't even think.
Have you met Musk?
No, have you?
Yeah.
Oh, really? No.
Yeah, we had dinner together.
Did you really? Oh.
Yeah. It was before he was quite as famous.
Where was that?
Oxford.
Was he at some event or?
Yeah, we were both at an event and we got sat across the table from one another.
That's good. Is he one of us?
He's more the business side of you that I don't understand.
Mm-hmm.
So dinner ended up becoming a discussion of when to buy versus when to rent and mortgages and
never. Let me guess. Never buy, always rent.
Yes.
Yes. Agreed. Never buy. Always rent. Seth Cooper, can we turn the moon into a fuel depot? Can we turn the moon into fuel? Yes. Not only that, but you can actually build a space elevator on the moon and it'll work like a charm.
Mm-hmm. True.
Ruppenthal says, I grudgingly take a stand for Taurus, but the O'Neill cylinder seems like a more flexible design, more easily expanded upon. All right, well, I think we are just wrapping up, nearing the end of our hour. And yeah, I kind of do need to go and get on this whole Musk news, get the team cranking. So,
okay.
We've got a beautiful story coming out very shortly. I don't know if it's done yet. We have found this wonderful visualization of UFO sightings.
Uh-huh.
So apparently Americans are 300 times more likely than the average, the rest of the earth, to report UFOs.
Oh, wow.
300 times.
Wow.
Yeah. Guess who's number 2?
Canada?
Yeah. Yeah, because we're your cousins. So.
You're our cousins everybody likes.
Okay, cool. Well, let's wrap things up. Thanks, everyone, for watching. Big thanks, Pamela, for bringing the brain. Thanks, as always, to the WSH crew for staffing the chat room. If you want to take your love of space and astronomy to the next level, go to wshcrew.space and you can join the community. They'll help you get into the Slack channel, and then you're hanging out with us. And I'm in there, Pamela's in there. Like, if you want to just chat with us, that's the place.
Add us.
Yeah. Okay, cool. I think I'm going to do a live show on Instagram later. I'll turn that on and chat with people about the SpaceX announcement. So once I've wrapped my head around it, I'll show up on Instagram probably in like an hour or so. So if you
I have a
haven't
NASA
already,
report to write.
do you really? So if you haven't already, follow Universe Today on Instagram, and you'll get an announcement when we go live. All right. Thanks, everyone. We'll see you all next time. Friday?
Thursday potentially. We're still working. I'm on a plane.
I understand.
I'm.
No, I
It's
understand.
March. I do this in March.
No problem. All right. See you later.